Land Rover dominates this specialist market sector, despite the best efforts of its competitors, and the company has almost single-handedly created the luxury 4x4 sector with the Range Rover. More recently, it has taken a large slice of the 4x4 leisure market with Discovery. To build upon that success and to increase its share of the small and medium four-wheel drive leisure sector, Land Rover now introduced the exciting new Freelander range of vehicles. Freelander isn't designed to compete with other Land Rover models. It's a compact 4x4 aimed directly at the leisure market, but still maintaining clear links with its illustrious heritage. It fairly bristles with innovative features. A rigid and technologically advanced unitary body and chassis construction, permanent four-wheel drive, independent suspension all-round, a unique braking system, a transverse engine layout, and a sophisticated security system. Freelander is available as either a 5-door, 5-seater station wagon or in 3-door, 4-seater and 5-seater form. The versatility of the design is illustrated by the fact that the 3-door can have either a soft back or a hard back, and they're both detachable. Both models are available with petrol or diesel engines and are designated I and DI respectively. Variants with a higher specification are referred to as XEI and XEDI. All models have a very comprehensive specification, including a radio cassette with 4 speakers, driver and passenger airbags, seatbelt pretensioners on the front seats, electric front windows, central door locking, a comprehensive alarm and immobilization system, and a tiltable steering wheel. Incidentally, all 3 doors have an integral rollover cage for safety and these removable Targa panels. XEI and XEDI models include additional features such as alloy road wheels with locking nuts, a 6-speaker radio cassette system, and ABS braking. Incidentally, ABS operates in conjunction with a totally new and patented hill descent control system, which provides automatic braking control under certain conditions. Then there are a number of options too. For example, air conditioning and metallic paint. The hardbacks and softbacks are interchangeable on XE 3-door models. You can find a full description of the model specifications in the appropriate sales literature. Engine selection was easy. 2 options, petrol and diesel. Both are well-proven units already available within Rover Group products. The 1.8-litre K-Series petrol engine and the powerful 2-litre L-Series diesel. Another tried and tested unit, the transversely mounted PG1 5-speed manual gearbox, transmits drive to an intermediate reduction drive unit, or IRD for short. The IRD delivers drive to both front wheels and to the rear axle through a 2-piece prop shaft split by a viscous coupling. The coupling serves to control the difference in speed between the front and rear prop shafts. Now let's look at security. Freelander has a sophisticated security system, controlled by a central control unit, or CCU. The CCU is located behind the fuse box under the fascia. It must be programmed to provide a setup to suit each individual market. This is carried out using Testbook. The CCUs will be set in a transit mode when you receive your vehicles. This is a power-saving mode where some features are disabled to reduce quiescent drain during the transportation process, and you'll need Testbook to remove it at PDI. In addition to setting the market option, further features can be programmed using Testbook to personalize the vehicle setup. But rather than detail all of them in this program, we'll concentrate on the main features. It's got central door locking, perimetric and volumetric protection, and engine immobilization. The vehicle can be locked, super-locked and armed using the key, and will be super-locked and armed in response to the remote handset. This switch on the center console will centrally lock the vehicle, but will not arm the alarm. This is to provide security for the occupants while driving. If the key is turned once, the vehicle will lock. To superlock, the key must be turned twice. The second turn must be made within 1 second to be effective. Alternatively, the vehicle can be superlocked by pressing the handset lock button once. The unlock button is pressed once to disarm the system and unlock the doors on vehicles which don't have the single point entry feature set. We'll look at this feature in a moment. If the handset isn't available, then the key can be used to disarm the alarm, but this can only be done by entering the emergency key access code, similar to the way you do it on other Land Rover vehicles, although it's possible to have numbers in the code up to 15 on Freelander, and there's a 5-minute delay period after unlocking the vehicle before the code can be entered. A unique security feature on Freelander is single point entry, which we mentioned just now. It affects how the vehicle will react to an unlock request. From a superlock condition, press the handset unlock button once. This will unlock the driver's door only, leaving the other doors locked to prevent entry through them. A second press on the unlock button will unlock them all. The level of protection provided by the security system is dependent on the market requirements and the specific program state of the CCU. But in general, perimetric protection and engine immobilization occur with both key and handset locking, and volumetric protection is enabled when the handset is used. In all markets where the security system is enabled, the hazard lights will flash when you lock or unlock, and they may also flash when the alarm is sounding. This is one of the features you can program with Testbook to suit customer preference. All Freelander models are equipped with passive immobilization and remobilization. The engine will be robustly immobilized automatically 5 seconds after the ignition has been switched off and the driver's door opened. It will also immobilize 5 minutes after the ignition has been switched off, even if the driver's door isn't opened. Remobilization occurs when the ignition is switched on, provided a valid handset is fitted to the key ring. Alternatively, a press on the unlock button will also remobilize the engine. This LED will flash rapidly for 10 seconds when the alarm is successfully armed. It then slows to flash once per second until it's disarmed. If the alarm has only entered a partially armed state, due to an insecure panel for example, then the LED won't give the fast flash, but instead go straight into slow flash mode after 10 seconds. Full arming can be achieved by closing the open panel, unless it was caused by an open driver's door, in which case a further arm request must be sent. Vehicles are supplied with 2 handsets, but will operate with up to 4. The handset is fitted with a single battery, and if it reaches a low state of charge, a warning will be given by the CCU when the vehicle is unlocked using the handset and the driver's door is opened. You can change the battery in the usual way. A couple more points before we leave security. The driver's door can't be slam locked. The passenger's door can. And if the handset becomes unsynchronized to the CCU, press any combination of buttons 5 times. Alternatively, make sure the handset is attached to the key, then turn the ignition on. Finally, the CCU will record the cause of the last 4 alarm triggers, so you can use Testbook to examine the recent history of the alarm. Incidentally, Testbook plugs in here behind the center console, on the left on right-hand drive and on the right on left-hand drive. As we said before, Freelander security is important, as is an understanding of its market variations and functionality. We suggest you consult the appropriate service literature to establish the specific functions of the system in your market. Testbook will also help you to do this. Now let's have a closer look at the tail door and its drop glass we mentioned before. They both operate under the control of the CCU. The glass can be opened and closed using this switch on the center console. When one touch is set, if the switch is held down for less than 0.2 seconds, the window will fully open in one continuous operation. Alternatively, hold the switch for longer and the window motor will operate until the switch is released. For convenience, the drop glass can be opened using the handset, so you've got access to the luggage area without opening the door. Press the unlock button and hold it down for about 1.5 seconds. The window can then be closed by using the switch inside the vehicle or by holding the key over to the lock position. Particular attention has been given to glass sealing, and an ingenious design is used on Freelander. The glass actually locates up into the seal. To allow the door to be opened and closed, the window lift motor will automatically lower the glass to clear the seal before it allows the rear door to open. The CCU controls its operation. It receives signals from the door latch mechanism, so when you pull the handle, there's a built-in delay while the glass lowers before the door latch will release. And the glass will raise automatically after the door has been closed, but it won't happen unless the door is fully closed. To enable the CCU to control the window operation accurately, it must be aware of the position of the glass, so a setup procedure is necessary. Vehicles will be set up at the factory, but if, for example, the battery has been disconnected or if the glass has been moved, you'll have to carry out a simple recalibration procedure. Do it like this. First, ensure the rear door is closed, then connect the battery. The window will immediately go fully down and the CCU will set its position. Now turn the ignition to position 2 and hold the window switch until the glass has reached the top and stopped moving. The CCU will have counted the motor revolutions and will set its fully closed position. Full operation is now restored. And while we're talking about the tail door glass, this switch on the D-post on 3-door vehicles ensures that the glass drops automatically if the roof is removed or if the hood is folded forward. This prevents the possibility of driving away with the glass up, unsupported. Now we'll move on to the braking system. Disc brakes are fitted at the front and drums at the rear. By the way, in case you've been looking for a transmission parking brake, there isn't one. Instead, on Freelander vehicles, the parking brake mechanism applies the rear brakes. ABS braking is fitted on all XE derivatives. The modulator is fitted here under bonnet, and inductive type wheel speed sensors read from tooth reluctors on each wheel. The ABS ECU is located under the right-hand front seat. It controls the ABS and a 4-wheel electronic traction control system. In addition, it also controls the revolutionary hill descent control system. ABS prevents unwanted wheel lock in all braking conditions. Electronic traction control serves to enhance the vehicle's traction in difficult conditions through automatically controlled brake application. Hill descent control, or HDC, is primarily an off-road feature and only operates in first or reverse gear. It automatically applies the brakes momentarily, repeating as necessary when the vehicle is descending a hill, and allows the driver to maintain effective control of the vehicle. The clues to knowing whether HDC is fitted are this yellow switch on the gear lever and 2 lights. Press the yellow button and push down the collar to make the system operational. This green light in the instrument panel illuminates to indicate that the system is ready to operate when HDC is activated and first or reverse gear is selected. It'll flash if you're not in the right gear. This amber light illuminates if certain faults develop. As we've just said, the ECU will operate HDC when it's switched on and first or reverse gear is selected. It uses signals from a number of sources: the yellow control switch, gear switches to detect first and reverse gear selection, a road speed input, and information from the engine management ECM on engine type, throttle position, engine speed, and engine torque. In summary, providing it's switched on and first or reverse is selected, the HDC system works like this. The ECU is programmed with two target speeds, 6.5 kph in reverse and 9.6 kph in first. If the vehicle speed is greater than the target speed, braking force is applied to one or both axles to keep the vehicle travelling as closely as possible to the target speed and enable the driver to concentrate on steering control. If necessary, the driver can increase the vehicle speed by pressing the throttle. When the throttle has been released, the ECU will apply braking force to bring the vehicle back to the target speed. The brakes can be applied during HDC operation to bring the vehicle to a standstill if necessary. By the way, the ECU automatically illuminates the brake lights whenever it applies the brakes during HDC operation.
Now let's have a look at the drive line. Under the vehicle you can see the layout. Here's the PG1 gearbox we mentioned earlier. And this is the IRD unit and the drive to the front wheels. Incidentally, the IRD uses an oil-to-coolant cooler, and these are the coolant pipes. The IRD unit provides a gear ratio reduction. It drives the front wheels, and is the means of turning the drive through 90 degrees to drive the prop shaft and rear wheels. This diagrammatic view of the IRD will help you get a better idea of what's inside it. Drive from the gearbox turns this primary gear shaft, which in turn drives this lay shaft. The lay shaft drives the front differential. The differential contains the usual sun and planet gears and delivers drive to the front wheels via the front drive shafts. As you can see, the intermediate shaft goes right through the centre of the primary gear shaft driven by the gearbox and connects the left-hand drive shaft with the front differential. Sealing is very important here because the gearbox and the IRD use different oils. Drive to the rear axle is taken from the left-hand end of the lay shaft, where it's angled through 90 degrees by a hypoid gear which turns a pinion and the prop shaft. The prop shaft delivers drive through a viscous coupling to the rear axle differential. The viscous coupling is located on two bearing assemblies. These are secured to the vehicle body and must be positioned perpendicular to the shaft. The viscous coupling ensures that the desired level of drive is delivered to the front and rear in all conditions and will act as an automatic diff lock in certain conditions. The rear axle is rubber mounted within a subframe and drive is finally delivered to the rear wheels by the rear drive shafts. The driveline as a whole helps to ensure that Freelander vehicles deliver on-road performance while maintaining off-road capability. Freelander has independent suspension all round, using McPherson struts. The design enabled Land Rover's engineers to maximise first-class on-road refinement and road-holding characteristics with excellent off-road capability. An additional feature on the front suspension is that the mountings have been carefully designed to assist energy absorption in the event of an accident. Power-assisted rack and pinion steering is used for the first time on a Land Rover, providing a light and positive feel. Front wheel alignment is adjusted on the track rods. At the rear, each McPherson strut is secured to these two radius arms and located by this trailing arm. The rearmost radius arms are adjustable for length to enable accurate adjustment of rear wheel alignment.
By the way, you may be wondering about service schedules. The first scheduled service is at 3,000 miles. The main service is carried out at 12,000 miles and thereafter at 12,000 mile intervals. Before we finish, a word about accessories. We mentioned earlier the deliberately planned intent to aim Freelander at the leisure market. So to maximise its appeal, there's a vast range of accessories available, about 100 in all, ranging from a leather-covered steering wheel to wind deflectors, and from a dog guard to booster cushions. The availability of these accessories aligns with Land Rover's philosophy of flexibility and practicality, and in addition, it makes it possible for customers to personalise their vehicles. That completes this introductory technical video on the new Freelander. a vehicle with tremendous appeal to a whole new sector of the vehicle buying public. You'll be seeing a lot of new customer faces, so make sure you can look after their interests by getting to know Freelander thoroughly.